Today we are going to look into the parallel and non-parallel vector. Here you can see the one I draw here. We have vector CD, we have vector AB, vector AO, OB. You have vector EF again. So we can see CD, the vector is negative 4i minus 3j, and parallel with vector negative AB, which is negative 8i minus 6j. So AO is negative 3i minus 4j, and parallel with EF, which is negative 9i minus 12j. Okay, so now I wanted to look at this CD and AB. These two vectors, they are parallel, right? AO and EF are also parallel. So we can actually see the relation here because AB is longer, right? So from negative 4 to negative 8, we times 2. From negative 3 to negative 6, we times 2 also, right? Can you see the ratio between them? From here we can make the conclusion also. AB is actually 2 times of CD, which is negative 4i minus 3j. Do you see that? If you look at AO and EF, you can see the same thing also. From AL to AF is actually times 3, right? Not only the I, the J also the same. So negative 3 times 3 become negative 9, negative 4 times 3 become negative 12. It gives you the idea of EF is actually 3 times AO. So with that, we made the conclusion that the ratio between AB to CD is 2 to 1. The ratio between EF to AO is 3 to 1. So this is what can we see from the parallel vector. We can actually get the ratio between them. What happens if we compare the vector? We compare the vector which is not parallel. For example, I compare the CD and EF. I compare the AO and EF. They are not parallel, right? Can we get the ratio between them? Try to have a look. Negative 4 to negative 9, we multiply with what value? 2.25. Correct? But if you see from negative 3 to negative 12, we times 4. These two, they are actually different value, right? Different value you multiply. So we cannot actually factorize any value here from negative 9 and negative 12 to make the negative 4i minus 3j appear. So which means there is no any ratio exists between CD and EF. Same to AO and AB. Here already I write it down here. Same to AO and AB, you realize that negative 3, you have to multiply 8 over 3 to get negative 8. Negative 4, you multiply with 3 over 2 to get negative 6. Again, you can see they are different. So once you have the different value here, we cannot factorize any value out to get the ratio between AO and AB. So this is what happens if the vector are not parallel. So from here, we can make the conclusion that if we look back to the parallel vector, for example, AB and CD, then the ratio will always exist between the two vectors. In this case, is AB and CD. And the ratio, we label it, we represent it using lambda. But of course, the lambda here cannot be 0. It can be 1, can be 2, can be 3, can be half, can be 1 over 4, but cannot be 0. Once we put the 0 in, then the ratio will be gone. Correct? So with that, we can make another conclusion that if the two vectors are not parallel, for example, CD and EF, they are not parallel, right? So if we compare them with lambda, then the lambda will be 0. Why? Because that is the only value to show that the ratio is not exist. I repeat again. If they are parallel vector, the ratio will exist between them. The ratio shows that which vector is longer and which vector is shorter. But if non-parallel vector, the ratio is not exist. So that's why the lambda will be 0. Alright, let us have a look on how we supposed to apply the concept of parallel and non-parallel vector in the SPM question. So we start with SPM 2013, paper 1 question. So let us see, you are given vector U is 3, 4, vector V is 6, K minus 1. Okay, firstly, the question asks you to find the unit vector in the direction of u. So this one you must understand. 3, 4 here, it will give you a magnitude of 5. How to find it? Referring to the Pythagoras theorem. And always remember that unit vector means the vector with one unit. So if the original vector is 5 unit, to make it become 1 unit, just divided by 5. So you can either leave your answer as 1 over 5, 3, 4, or 3i plus 4j over 5. Either the column vector form or the ij form. It depends on the question. So since this question did not request for any form, we can leave our answer in any form you want. Okay, 1 mark for this question. Now, let us look at the second questions. The value of k such that u and v are parallel. U and v, these two vectors, they are parallel. So remember that, please recall back the concept of parallel. If they are parallel, it means that one of the vector should be longer if compared to another vector. We know that if they are parallel, means they always have the ratio exist between the two vector, right? And if you don't know the ratio, we add the lambda. So you can either add the lambda in front or you add the lambda at the back lah, up to you. So in this case, I show you the example if I add the lambda in front of the u. Let's see what happens. So we substitute the vector inside. So lambda 3, 4 is equals to 6k minus 1. Then after that, we can compare x to x and y to y already. So lambda times 3 is equals to 6. So do you realize that we can actually get the value of lambda, which is 2? Then we compare again the y, put the lambda in with 2. So 2 times 4 is equals to k minus 1. With that, we move the negative 1 to the other side, it will become plus 1. So your final answer will be 9. Okay, this is how we find the value of k if we add the lambda in front. Again, the lambda is just a symbol for us to use to represent there is a ratio exists between these two vectors. So don't confuse by that. You can use any unknown actually. You want to put m ga, n ga, alpha, beta, whatever unknown also can be used, but not the unknown already used in this question. For example, k. If you use k here and the question itself already got k, you will confuse which k you are finding later on. Okay, so beside this one, we can actually add the lambda in front of the v also if you want. So that's why I say the lambda only represents the ratio. You can put in front or you can put at the back. So if you put at the back, the way we do is the same. 3, 4, and then you put in also 6k minus 1. It's just that the value for lambda you get here, it will be slightly different a bit because 3 is equals to lambda times 6. You will get the lambda 1 over 2 here. And then if you compare the y, it will become 4 equals to 1 over 2 times k minus 1. And you move the 2 to the other side times with 4, you will get 8. So 8 plus 1, you will still get 9. Okay, how we supposed to understand the value of 2 and 1 over 2 here? Okay. If the lambda is 2, then you will understand this one as 2u equals to v, right? What does it mean by that? Vector v is 2 times of vector u. So which means vector v is a longer vector, correct? Can you see that? V is actually 2 times of u. V is 6. The u is 3. And the answer is 9, right? So which means 9 minus 1 is 8. So for v is 8. U is 4. So that's how we get the answer. That's why for the first condition, we get the lambda 2. Why? Because v is 2 times of u. But for the second condition, we get u is equals to 1 over 2v. Correct? We understand this one as u is half of v. Same meaning, right? So actually, we got an easier way for you to solve this question, you know, because we can directly see the relation between these two parallel vectors u and v. Can you see that from 3 to 6, we times 2, right? This is the one that you can see it easily from the vector itself. So 3 times 2 is equals to 6. So from here, we can make the conclusion that, oh, the 4 we times 2, we will also get k minus 1. So we write down 4 times 2 it will give you k minus 1. Do you notice that this method is actually almost the same as the first method we use here? It's just that the first method, we do not know the relation between these two vectors. So that's why we use lambda to represent that value. But for the third method here, we actually can see it easily from the value itself. So we will get the same answer, which is 9. So for this part, we get 3 marks here. First method and second method, the marking scheme is the same. As long as you compare the x in order to find the lambda, you will get the 1 mark. So once you get the lambda and then you substitute inside when you compare the y in order to find the k, you will get your second mark. Third mark, of course, your answer k is equals to 9. If you are using the third method I mentioned here, first mark will be given once you identify the relation between the vector, which is times 2. So second mark is when you times 2, when you apply the times 2 with the y. So 4 times 2 equals to k minus 1. The third mark will be your answer, k equals to 9. Let us look at the next questions. SPM 2007, paper 1. Okay, so let us look at this question. You are given a trapezium A, B, C, D. And the vector P is 3, 4. Vector Q is k minus 1, 2, where k is a constant. Find the value of k. This question is very similar to the question just now, but the question did not tell you P and Q are parallel, correct? But from the diagram, they already tell you these two vectors are actually parallel. And what is the value of k? I will show you the first method, which is adding lambda. So when you add lambda, again, you can either add in front of P or in front of Q. So we add in front of Q lah. Actually, the same also in front of P or in front of Q. Yang penting. Next, we substitute with the vector inside 3, 4 and k minus 1, 2. And then we compare one by one. For this question, it's easier for us to compare from the y first, right? So 4 is equal to lambda 2, so lambda will give you the value of 2. Then we compare the x. 3 equals to 2 times k minus 1, and then we move the 2 to the other side, we move the minus 1 to the other side, become plus, you will get your final answer, 5 over 2 or 2.5, correct? So this one is a very simple question. If you are applying this method, either you put lambda in front or at the back like the one I show you here. First mark will be given when you compare the y to get the lambda. Second mark when you compare the x with the substitution of the lambda with 2. Third mark will be your answer, k equals to 5 over 2. But I believe that a lot of you can see the relation already, because from the 2 becomes 4 times 2. This is actually your lambda, right? So that's why I keep saying lambda is a value represent the ratio between them. So from here we can make the conclusion also. This k minus 1, if you times 2, you will get 3. So 2 times 2 equals to 4. So 2 times k minus 1 equals to 3. So with that, we will get our final answer also, which is 5 over 2 or 2.5. 1 mark for you to write down 2 times 2 equals to 4. 1 mark for you to write down k minus 1 times 2 equals to 3. And 1 mark for you to get the final answer. Okay, let us look at the next questions. SPM 2014, paper 1. Given vector P is negative 4, 3 and vector Q is 2k. Now, they want you to find the magnitude and then they want you to find the value of k such that vector P plus Q. This question is slightly different a bit. P plus Q is parallel to the x-axis. This question I'm going to discuss with you together, but of course we try to answer the question A first. We want to find the magnitude of P. Okay, and this is a vector P. So, and we understand the vector P is actually moving back by 4 units and then moving up by 3 units. So that's why the length is actually the 5. So that is our first answer. So the calculation is actually square root negative 4 square plus 3 square, then equals to 5. But our working, the working itself no marks lah. The marks is given here. Okay, next, the value of k such that P plus Q is parallel to the x-axis. So you know that if parallel, then the ratio must exist between them. But the thing is, we have to find out P plus Q first, right? Okay, we find P plus Q first. So P plus Q, it will be negative 4 plus 2. It becomes negative 2, correct? And the Y will be 3 plus K. It still remains 3 plus K. That one no problem. So I write down the vector here. It will be negative 2 and 3 plus K. But the problem is x-axis. What is the vector for x-axis? The Y will be 0. But the X we don't know, right? So we label as X only. So this is how we understand the vector for x-axis. And we know that they are parallel. So in this case, we know that there will be a ratio exist between them because of the concept of parallel, correct? So we try to compare it with lambda, and we compare x to x, we compare y to y. But if you look back to the question, what the question actually want, they want you to find the value of k, right? So do you realize that we can actually just compare the y? 3 plus k equals to lambda 0. You will directly get the value of k already without comparing the x. So 3 plus k equals to lambda times 0. With that, we will get the value of k, which is negative 3. 1 mark will be given when you compare 3 plus k is equals to 0. 1 mark will be the answer, k equals to negative 3. Okay, how we supposed to understand these questions? X-axis is actually a straight line, you know. It's a horizontal straight line where the y is 0, but the x is never ending. We never know how long is x-axis. It's infinity, right? We never know. But for sure, we know that the y will be 0. It's a horizontal straight line. So if you refer to the vector negative 2 p plus q, negative 2k plus 3 plus k, in order to be parallel with x-axis, this vector of p plus q, it must be a horizontal straight line vector also, right? I repeat again, because x-axis itself is a horizontal straight line. So in order to be parallel to x-axis, the vector of p plus q, it must be a horizontal line also, right? So in order to make the vector becomes a horizontal line, then your y must be 0, 2. Betul kah? And in order to make the y become 0, then the k must be negative 3. So that is the reason why our answer is negative 3. So that's why the working here actually very simple. No need to show the first step, the one yang equals to lambda x0. You can directly start with 3 plus k is equals to 0, and then you will write down the answer, k is equals to negative 3, 2 marks. Okay, now this is a question for parallel to x-axis. If the question say parallel to y-axis, for example, I write down here parallel to y-axis, then you must understand at the y-axis, the x will be 0,
X.
right? So which means you have to make sure the vector which is parallel to y-axis must be always vertical straight line. Vertical straight line means your x must be 0. So you just let the x, the whole thing, let it be 0, and then you try to find if got any unknown there. Let us proceed. Okay, now I show you the Cartesian plane again, a straight line, EGF. Of course, within this EGF, we can see a few vector inside, right? Do you realize that you got a few vector inside? EG, GF, and EF, and we call this EGF are collinear, correct? And the three vector I mentioned just now, EG, GF, and EF, they are all parallel. So that's why we can make another conclusion that when EGF are collinear, then EG and GF, they are parallel. EG and EF, they are parallel, and also GF and EF also parallel. If they are parallel, the ratio will always exist between them. So that's why we can make another conclusion, which is EG equals to lambda GF, or GF equals to lambda EF, or EG is equals to lambda EF. Okay, let's say my question is shows the A, F, C are collinear. So collinear means they all stay at one straight line. You can look at the diagram. AFC, it looks like staying on one straight line, right? But in mathematics, we cannot just make assumption that they are a straight line if the question did not tell you. So that's why the question give you the vector AC, AF, AFC, and AF, and they ask, can you please show to us that they are collinear? We need to show whether the vector are parallel or not, right? Betul kah? We need two vector from these three. Actually, it can be ACFC, ACAF, and FCFAF. Can choose any vector here. Oh, for the first example here, I choose AC and AF. So AC is 5x minus 2y. So I can actually factorize the 5 out. Do you realize that? It will become 5 bracket x minus 2 over 5y. So AF, we can factorize the 4 out. It will become 4 bracket x minus 2 over 5y. Correct? Do you realize that both of them, it will give you x minus 2 over 5y? So try to imagine if I divide the AC with AF. I divide both of these vectors. This one I divide. This one also I divide. Then I will able to cancel off these two vectors, x minus 2 over 5y, and it gives me 4 over 5. What does it mean? It gives me the idea that AC is 5, AF is 4. Right? AC is 5, AF is 4. Then FC will give you 1. Do you realize that the ratio already came out? So remember what I say, the concept of if two vectors are parallel, then the ratio will exist between the vector, right? So with that, we can make the conclusion that 4AC is equals to 5AF. Or if you don't want to, if you don't want to write in this form, you can also write it as AC is equals to 5 over 4 AF. So in this case, your 5 over 4 will be your lambda lah. Like I said before, the lambda represent the ratio, the value which gives you the ratio between the two vectors. With that, we can make the conclusion AFC are collinear. To prove whether the points are collinear or not, we have to prove that they are parallel. But do you think every parallel vector will be collinear? No, right? Not every time they are collinear. Okay, now I show you two examples here. So the first example, let's say AF, okay, and equals to I give you the example of this lah. AF equals to 5. Oh, never mind. I follow that one. AC is equals to 5 over 4 AF. Okay, I give you the second one. AC is equals to 5 over 4 KF. My first question is AC and AF, are they parallel? Yes. AC and AF,
Yes.
they are parallel. Correct? So now I want to ask, AC and KF, are they parallel? Know that they are parallel. Why? Because there is a number exists between the two vectors, and that lambda will give you the idea of ratio, right? Okay, now I want to ask you again. AC and AF, are they collinear? Okay, the answer is yes. The point of A, C, K, and F, are they collinear? No. Okay, now my question is why? Why the first one we know they are collinear, but the second one they are not collinear? Do you realize that for the first case, they share the common point, A, right? But the second one, they do not have any common point. What does it mean? Try to imagine that if for the first case kan AC is like this, from A go to C and then from A go to F. Since they show the common point and they are parallel, the only possibility for you to draw them is you must draw them within a straight line. Right, so that's why A, C, F are collinear. But if you look at the second one, AC is here. This one we draw AC. But KF may be somewhere else, right? Because they are not connecting. So that's why for the second case, we cannot say they are collinear. We cannot say A, C, KF are collinear. But for sure, they are parallel. Okay, because the ratio is exists between them.
So the calculation yang prove that they are collinear.
As long as you can get the ratio between the two vectors, then it's already proven that they are parallel. But to know whether they are collinear or not, you must check whether they have the common point or not. That's why when I come up with this conclusion, this one, uh, or this one, AC equals to 5 over 4 AF, then I can actually make conclusion already. Why? First, I can get the ratio. Second, I can see the common point. Actually, not necessarily AF and AC only lah. You can refer to other point also. For example, AF and FC. Okay, so if AF and AC, so let us see what will happen. So FC, no need to factorize anything. FC itself is already x minus 2 over 5y. So we can directly get the ratio between them, which is 5 to 1, right? So we can write down AC is equal to 5FC, and then we check again. Yes, they are parallel. Why? Because they have the ratio between them. Second, they have the common point or not? Yes, they have the common point, which is C. So with that, we can also make the conclusion AFC are collinear. Okay, even though the value of the lambda is different, even though you are referring to the different vector, but as long as they fulfill these two conditions, parallel, the ratio is exist and they are having the common point, then we can make the conclusion they are collinear. Okay, for then can you take picture and screenshot?
Okay, sir.
Okay, let us look at the next one. If I refer to AF and FC, can also. Because AF, I factorize the 4 out. Then FC itself is already x minus 2 over 5y. So I can get the ratio again 4 to 1. And then I can make the conclusion again. AF equals to 4FC. You can see the ratio. You can see the common point. You can also make it as, you can also make the conclusion AFC are collinear. So this kind of question, usually you got the freedom to choose any two vector that you want to use to prove that these 3 points are collinear. Okay, what if some people they are facing some difficulty to find the ratio? Maybe the vector too complicated. They do not know how to divide it, how to factorize and how to divide it to get the ratio. Okay, if there is a case, we can refer to lambda because the question want you to prove, right? So the lambda is actually the ratio. So we add the lambda, then we try to find out what is the value of that lambda. Okay, we refer to AC and AF lah. You can choose any 2 point actually. I just show you one example only. We choose AC and AF. And then we add lambda between these two vectors. Let's say I add lambda in front of AF. Can be in front of AC also. And then we substitute the vector inside. So 5x minus 2y equals to lambda bracket 4x minus 8 over 5y. So after that, we compare x to x and y to y. So for x, it will be 5 equals to lambda times 4. For y, it will be negative 2 equals to lambda times negative 8 over 5. So can you see that both will give you the same value of lambda, 5 over 4 and 5 over 4? Do you remember the example I showed you just now? If the vector are not parallel, impossible you will get the same value of lambda. Correct? Just now I show you already when the vector are not parallel, you might need to multiply with different value for x and y. But this one is the same. So once you get the same value of lambda, it is proven that they are parallel. So we put back the value. See that? Again, we can see the lambda which represent the ratio between the two vectors, and we can see the common point here which is A. Then we can make the conclusion A, F, C are collinear. So same method can be done if you choose the different point, different vector. Yang penting you can get two things here. One, the ratio. Second, the common point. In the case that if you get different value of lambda, that will prove that the vectors are not collinear and not parallel. Okay, next. Not every time the question will ask you to show or prove they are collinear. Sometimes the question will directly tell you, oh, AFC are collinear. Find the value of M. So it already tell you. So which means from the statement itself, you already know, oh, they are collinear. So which means the vector AF, FC, and AC, they should have certain ratio between them. And if you look at the question, they give you the same information, AC, FC, and AF, same as the one I showed you just now. But it's just that this time I change one of the number becomes M. And my question is, I want to find the M. Okay, in this case, I use lambda lah. Then we have to choose any two vector from here. So the example I use here is AC and AF. It can be any two vector here. Okay, let us see AC and AF. And we add lambda. We can add in front of AF or we can add in front of AC. That one up to you. Okay, so we just stick to this in front of AC. So we substitute the vector inside. So vector AC will be 5x minus 2y. Vector AF, it will be 4x plus my. And we know that the value of lambda will be the same if they are parallel, correct? So we compare the coefficient of x. So 5 lambda equals to 4. Now we compare the coefficient of y. Negative 2 times lambda equals to m. So let us see. Lambda is 4 over 5, right? So with that, we substitute the 4 over 5 into the lambda at the other side. 4 over 5 times negative 2, I will get my m, which is negative 8 over 5. It's exactly the same value as the one I showed you in the previous example. Okay, so this is how we find the m by referring to lambda, by adding lambda inside, by adding lambda between the two vectors. But some people, maybe you feel that we can directly get the ratio between them, right? For example, if you are referring to AC and AF, if you are referring to AC and AF, any two vector actually, we look at AC and AF first. AC and AF. From the 5, how we actually get 4? Tell me. We multiply with 4 over 5. Correct? 5, you multiply with 4 over 5, you will get 4. Same thing also, negative 2. If we multiply with 4 over 5, we will get m. So that's why the answer is negative 8 over 5. This is how we do it if you want to directly compare. So if you want to directly compare FC and AF also can. This one easier a bit. Why? Because the value is 1. And you know that from 1 you go to 4, you just have to times 4. Right? So with that, we know that negative 2 over 5, if you times 4, you will get your m, which gives you negative 8 over 5. So this is considered the shortcut lah. How we find the value of the unknown based on what we understand here. But of course, if you cannot see the ratio between them, or you don't know what value you're supposed to multiply in order to get another vector, then we just get use of lambda to help you to identify.